Hello! Today we're going to talk about extending Python modules with C. This is a somewhat advanced topic in Python because it requires you have an understanding of Python and C. These are two programming languages. So if you're not amazing with C, but you're rather good with Python, or vice versa, you'll probably get through these videos just fine. But if you have a little bit of trepidation with the idea of doing both Python and C, feel free to check out some more introductory videos before checking out this one. Without further ado, let's move forward. So some background. Why would you want to extend Python with C? Well, the idea of extending Python with C to make it faster, it's not a new idea. There are many third-party libraries in existence right now that make use of this concept. And by now, I'm sure many of you, if not all of you, have heard the phrase Python is a glue language, and it can be used to integrate with C, so C does all the redundant parts. And so using this concept loosely, you can basically make all the hard parts happen in C while all the easy stuff that makes everything connect together, you can do that in Python. And so you have an easy interface to something that is conceptually difficult to deal with. That's the basic idea. So that brings us to our first point. It satisfies the underlying requirement of parsing Python into C or C into Python. By creating an extension module, you can compile C and put it into a Python module and call it. It satisfies that. You don't have to learn a third language. So it's just C and it's just Python. You have to learn a little bit of boilerplate, which is just par for the course, but ultimately you have all the tools that you need if you understand C and you understand Python. It's easy enough to do for small things, and it can make things very fast. I'll show you an example in a couple of slides, and we'll go through the whole entire process of building. But bottom line is, when you compile something rather than interpret it, it's going to be faster. Bottom line, period. End of story. Okay. So why wouldn't you want to do something like this? Well, another issue is they're not going to be compatible forever. So you're going to see that when the API changes, or if anything in the underlying python.h file changes, you're going to have a hard time converting your module into something else, especially if you've built on it and maintained it for a while and you have to change all the moving parts again. That's going to be difficult. So if you have a big project plan for this, maybe consider something else, maybe C types, maybe libffi, or maybe even Python. When you're doing big things, it's a hassle. You have to deal with the compatibility issues if they come up, and you're going to have to deal with parsing every single C type and C function that you're dealing with. Even if you're doing some kind of struct, any kind of relationship, you're going to have to deal with it in Python. It's easy enough to do for small things, but big things, maybe it's not the right move. It also only works for CPython. So IronPython and PyPy, these things will not work with these C extension modules. These are singly purposed for CPython. So if you have CPython on your machine, great. If you don't, it's not going to work. With all this in mind, if you can find a way to make this work for you, then absolutely move forward. If there's another way that makes more sense, consider C types, consider libffi, consider Python. Those are perfectly good third-party libraries, and some of them, even C types, is completely part of the Python standard. So check those out. This is really specific use cases that you would really want to use the C extension modules, but hell, it is powerful. So without further, let's move forward. You made it this far. Let's keep going. Let's talk about the build environment for a second. So I'm using the Ubuntu distribution. It's stable enough for me. Kernel 5.9. I've got the GNU-C compiler on here, 9.3.0, and I've got Python 3.8.5 running for me right now. And that's really all I've got as far as build environment. I think that's really all you need for this. So let's keep moving. So we have a plan here. We need to work out a plan. My plan is first and foremost, you got to figure out what the heck you want your stuff to look like. Because this is an example, I can pretty much just write it with these 5 lines. I want to be able to import said example, import some function, and pass some values to it and get some output. That's it. That is the extent of this example. So this is the plan that we're going to work with right now. So here's my module. My module calls this function. This function has 2 inputs, and then it's going to print some output. That's it. So this is what you can expect in our example today. And then I have a nice infographic about that. Yes, the module, the function name, and the output. Let's talk about a full disclosure really quick. This is going to be a super simple example. We're not going to do error checking. We're not going to do any memory allocation or deallocation. We're going to completely ignore the fact that there is no garbage collector in these extension modules. You are working in C, but it's not super important to me right now because we're not going to do an example that needs those things. But you should keep in mind that this example does not capture those aspects. In future videos, maybe, but not this one. So keep your eyes and ears open and be very aware. So what's necessary for conversion? So you got this C function, right? We're going to call that C find primes. Why? Because a finding prime example is super easy to do. It's functional. It's 1 input, 1 output, or 1 input multi-output. They're integers. It's math. It's easy. We can do it. You're going to need a Pi object. So what does a Pi object do? It parses this C function into Python. It's going to look like boilerplate because it's a special C function. It uses the Python header. There's no straightforward translation from an argument list in Python to an argument list in C. So you have to use this boilerplate looking thing, which points to the argument as a tuple. And it's going to be the same basically every single time. It doesn't matter if it's find primes or something else. It's going to be basically the same. You can have a self input, and you're going to have an args input, and that's it. You see this kind of thing a lot in big C projects, and Python is no exception. Method definition, more boilerplate. You're going to put your C Pi object function into this method definition, pass some other parameters. Then we're going to go into this module definition where you're going to pass this method definition into this module definition, which can be initialized. So let's get into some execution, shall we? So let's have a look at find primes here. All right, so our first thing that we need to do is we need to check out find primes, make sure that everything looks correct. I have this flag variable in here, make sure that we come out of our loop when we found all of the functions that we need within the range. Great. All right, so this definitely works. It's a simple function. If you'd like to test it, you can copy it now. But let's create our Pi object. So self and args are the two functions that get passed into the C function. Why? Well, that's just Python standard. This is what we call boilerplate. Large C projects tend to have boilerplate, and this C project is no exception. So we have two values that get passed in. Num1, I'm calling it num1 and num2. We also have the return value. Let's just call it the status value. Now, if tuple. So what this is doing is it's saying that if there is no arguments passed in, here, return null. Alternatively, if there are, we're going to call our cFindPrimes function. We're going to pass in num1 and num2. So what this is doing is it's parsing the value of num1 and num2, which has been hopefully passed as a tuple into this args parameter here. And we're expecting 2 integers. And so it's taking the values inside of args and then pulling them out into num1 and num2. Otherwise, we're returning null. Then we have this status. So cFindPrimes is going to pass the input num1 and num2, which we parsed from this pyarg parse tuple. And we are going to return a pi long from long, because integers in Python are longs. I hopefully spelled this correctly. I think, yeah, camel cases. That's standard. Okay, now that we've written our findPrimes object, rather our pi object, which is going to take on the findPrimes function. So this is actually what we're calling. This is the parsed version of what we're calling in Python. We won't be calling cFindPrimes. We will be calling this. Although this is basically just wrapping the cFindPrimes and parsing it into C and then parsing it back. We actually, in this particular instance, we're not actually putting it back into Python. We are actually printing it from C. So there's no actual handoff between C and Python in this particular case, except for this return value of whether it succeeded or not. So keep that in mind when we're going to do a speed test in a minute. And, you know, I might just be pulling the wool over your eyes. This might be slower than it is. So let's do the pi method definition. Oops, that's not how you do an array in C. Okay. So our values here, our method definition is we have the findPrimes function. We pass the findPrimes function into it. So this is the string associated with this function. And then the meth or args. Let's do a quick description here. Prime numbers between all prime numbers between num1 lower bound and upper bound provided by given range. Cool. And now let's do a little version function here. We're going to convert this. Because we're not passing any Oh, did I not make? I didn't even make the version. Okay, so version just tells the module and anyone calling the module what version your module is in. So if you had a module like NumPy, it's useful to be able to tell the difference between versions. In our case, it's not super important, but it's kind of fun and it's good to know, just in case some of you are doing that in the future. Whoa, Nelly. Cool. String. Actually, this isn't a true version of anything, is it? No. It's just an example. We need a string. Cool. We need to close brackets on that. Struct. Okay. Here's some more. Boilerplate. I think this has a meaning. I'm not sure what it is. Sorry. Sorry for if you thought I was all-knowing, but I have no idea why this one's there. It says it in the documentation. I just forget. I haven't used that, so. More boilerplate. Well, this is it's basically boilerplate here. So we're gonna finish our example. By module def and so this is the module that we're adding. This is the name. The global state is going to be -1. And we're going to pass in our pi method def here as well. Great. Finally, our last bit of work here is we need to make an initializer function. This is all caps. Cool. And cool. So we're passing the find primes object into the pi method definition, which is passed into the pi module definition, which is finally passed into this initializer function. Great. Cool. Okay. This looks right. So let's make the setup.py, huh? Core import setup module equals, so the name of our extension is example. Our module is example. Are gonna be this file, example.c. Great. I don't have a name for this package because it doesn't show up anywhere in the actual calling of the function for me. Version, we put before that 0.01. And then we're going to have, we have a description. Hey, cool. So we have our sources, we have our extension, we have our package, we even have our help. Cool. And we're going to see these in a minute because I'm going to call them with IPython. Cool. Let me verify that's right. Yeah. From I can type. Great. Hey, I'm going to copy this. 2 directories out. Nice. So if I IPython import example, yes. Nice. Tells me everything about it. Cool. Alrighty. So we are in the final part of this test, and we have compiled our example module. We've built it. I'm going to quickly go over the example.c because I just went through a little montage of me fixing everything. So I'm just going to click through this very slowly so you can take in all the things that I changed. Not much. It was some slight errors here and there. I just made some mistakes. Yeah, really not a lot of code here to change. Okay, so that should be enough time. Okay. So if I open IPython, I can actually import the example, which is awesome. I also have access to the help functions that we created for ourselves. So it tells us what it is. It's the find params module. What it does not do is it does not tell us the types of args that go into it. And that's my fault. I didn't put those in there, but that's okay. This is just an example. We'll make another one where we add that. Okay, so now we have example. We can bring in, well, let's do version. Why not? We're at version 0.01. Well, that's true. We are. So I can actually print that. And version 0.001. Great. Another thing I can do is I can say example.find primes. And if I pass in a 1 and a 10, it'll give me the prime numbers between 1 and 10. Great. Look at that. So this is actually running in the compiled C code in the shared object file that we built. So I can do this also between 100 and 1000. Look at that, very fast. But that doesn't tell us a lot of information, does it? So I actually made this test file beforehand, which does 2 different types of tests. In this first test, you're basically looking at the time it takes for the C program to go from 0 to 100, and a Python version. So I actually have a Python version here, Python example. So this is a Python version of the find primes example that you see there. Okay, I'm going to run this file here. All right, let's go back. So let's ls. Okay, I'm going to run the test example, and we'll see what happens. Okay, it's going to start in 3, 2, 1, boom. Okay, great. So we've got this first test. Wow, mighty quick. 10 to the negative 5, 3 times 10 to the negative 5 seconds here. That's how fast the C, compiled C, found all of these primes. 1 is not prime, or maybe it is prime. Up to you. You decide. Is it prime? I don't know. Spoiler alert, it's not. And then we have 2 through 97. Great. So I'm going to do another test. That's test 2. So this was pretty fast. You barely can tell the difference between these two. So if you're doing something that's relatively quick in Python, you're not going to be able to tell the difference. But suppose I'm looking for the values between, I think this is 100 million. Say I'm looking for the values between 100 million and 100 million 100. Well, C found them pretty quick, about a second, a little bit more than a second. Whereas Python is really taking its time, about 22 seconds. And now if I run it again, let's see if it runs in cached. It's going to run the first one. Let's run the second one. Still wicked slow. The C version is going to be a little bit faster. I'm not going to touch the mouse at all. I am recording, but both the C and Python function are taking a hit because of my video recording and sound recording. Let's let that finish off, and then we'll call it a day here. 22.64. What was it before? It was 22.32. So actually a little bit longer than last time. Well, what are you going to do? Interpreted languages, am I right? So yeah, so that basically wraps up our example. Okay. All right. Well, that's all for now. Thanks for watching, and have a great night. Bye-bye.